Hey, welcome to The Explainer. Today, we are diving into a concept from computer science that's so fundamental, so powerful, you use it constantly without even knowing it. And it all kicks off with one simple question.
I mean, really think about that. You're typing, you make a typo, and bam, you hit undo, and it's like it never happened. Or maybe you're deep into a Wikipedia rabbit hole and you hit the back button. How in the world does your computer know the exact order of pages you just visited?
Well, it's not magic. It's actually just really clever organization. All those features depend on a specific way of storing information, a special recipe for arranging data so it can be grabbed at exactly the right time in exactly the right order. So let's zoom out a little. This whole idea of organizing information has a name. It's called a data structure. You can think of it like a digital filing system, a set of rules for how a computer should store and find information efficiently. Now, the textbook definition is pretty straightforward. It's just an arrangement of data in a computer's memory. But here's the key. It's not a random arrangement. The way it's arranged is everything. That specific structure is chosen for a purpose, and that purpose is what gives your software its power. And you know, there are lots of different ways to organize data, each with its own pros and cons. You've got things called queues, linked lists, trees, but today we're zeroing in on one of the most basic, the one that makes that undo button tick, the stack. The amazing thing about a stack is how intuitive it is. Seriously, forget about computers for a minute. Just picture a stack of plates in a cafeteria. If you want to add a plate, you put it on top, right? And if you need a plate, you take one from the top. You'd never try to yank one out from the middle of the pile. Well, that's it. That's a stack. This whole system runs on one single golden rule. Last in, first out. You'll hear this called LIFO. It just means the last thing you put in is the very first thing you take out. That last plate you added to the pile, it's going to be the first one to go. This one idea is the key to everything. And that brings us to the more formal definition. A stack deliberately limits your access. You can only touch the very last thing that was added. If you want to get to the item underneath it, you have no choice. You must remove the top one first. And it turns out this limitation isn't a weakness. It's actually its greatest strength. Okay, so how do we actually interact with a stack? Well, there are three main moves or operations we can do, and they have wonderfully simple names: push, pop, and peek. Let's walk through them. First up, push. It's exactly what it sounds like. This is how we add something new. Just like putting another plate on the pile, we push a new piece of information right onto the top of the stack. So if our stack has items A and B, and we push item C, the stack is now A, B, C, with C sitting right on top. Next, we have pop. This is how we take something off. And because of our last in, first out rule, we can only take the top one. So if our stack is A, B, C, and we pop it, we remove C. The operation gives us back the value C and leaves A and B behind. And finally, there's peek. What if you don't want to remove the top item, but you just want to, well, peek at it? That's what this is for. It lets you read the value of the top item, but it leaves the stack completely untouched. That's a huge difference. Pop removes it, peek just looks. All right, so we've got the theory down. We know the rules. LIFO, push, pop. Now for the fun part. Let's connect this all back to the real world, because this is where you get that aha moment. Think about it. Every single action you take in a text editor gets pushed onto an undo stack. When you hit undo, the last action is popped off of the stack and reversed. Your browser's back button, same deal. Every new page you visit is pushed onto a history stack. When you click back, the browser simply pops the last web address off of the stack. It's so simple, so elegant, and it's all thanks to last in, first out. So what does this look like when a programmer actually tells a computer to do this? Let's take a quick peek at the code. And don't worry, it's way more straightforward than you might think. It's just turning our plate analogy into simple instructions. So here's the push operation. On the left, the simple idea: add an item to the top. The code on the right is how you say that to a computer. See that little thing called top? That's just a marker for where the top of the stack is. This code just says, first move the top marker up by one, and then place our new item right in that spot. Simple as that. And here's pop. Again, the idea is just to remove the top item. The code does exactly that. It says, first, give me back whatever is currently at the top position, and then move the top marker down by one. This automatically makes the item below it the new top of the stack. It's a perfect mirror of taking a plate off the pile. And that's really the heart of it all. This incredibly simple logic. Last in, first out, managed with push and pop, is a fundamental building block of the software we use every single day. From your browser to the most complex scientific programs, stacks are in the background, quietly making everything work.
So, we've figured it out. A stack works like a pile of plates. The last one in is the first one out. But what about a line at the grocery store? That's not last in, first out, that's first in, first out. How would you build a data structure for that? We'll chew on that one next time on The Explainer.